All right, folks, today we are talking about traversing two-dimensional arrays. So if you remember back to our last class when we talked about 2D arrays for the first time, we have essentially what we're making is an array of arrays. So I've named it 2DR. It's got 1, 2, 3, 4, 5 rows and 1, 2, 3 columns. It is a 5 by 3 grid here. And the arrays within my 2D array are each storing integers. And I can access an individual element by first grabbing from a row. So 2D array at row 2 is going to be this row. And I can grab from a specific column within that row. That's going to get me that value 8. It's going to get me a single integer value out of my 2D array. Now, there are two different methods we can use, or two different ways we can go about accessing all of the elements in a 2D array, two different orders we can go. So we can either use a row major traversal, where we go through each row one at a time. So if I were to read the entirety of this 2D array with a row major traversal, my order would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we're just going across the rows and then going down the rows one by one. Now the alternative here is a column major traversal, where we travel down the columns one at a time. So if I were to read this entire 2D array with a column major traversal, our order would be 1, 4, 7, 10, 13, 2, 5, 8, 11, 14, 3, 6, 9, 12, 15. So we're reading down the columns one at a time. Now, the type of traversal that we choose is going to depend on our use case. So let's say we have a 2D array full of integers, and we're calling it gradebook. So it's going to store student grades for different exams. So let's say each row is a different exam, and each column is a student grade. So this is going to be the grades for student number 1, student number 2, student number 3, where each row is going to be a different exam that the students all took. So if I wanted to print out all of the scores for a specific exam, I would want to do a row major traversal. And if I wanted to print out all the scores for a specific student, I would need to do a column major traversal. So if I wanted to print out just the scores for exam number 1, we're going to have a for loop. We're going to loop across the length of gradebook at row 0, because that's how long that row is. We want to loop over all of the column values within that row. So we're going to print gradebook at row 0. It's going to give us that row. And then each time through the loop, we're going to get a different value of I. So we're going to print those out one by one. So we'll print out 90, 87, 86, 56, 96, 82. Now, if we want to do a column major traversal, instead of having the row be the value that, instead of having the column be the value that changes each time, now our row is going to be represented by I here. So we're going to loop over the number of rows. So we're going to loop while I is less than the length of our gradebook. And we're going to print gradebook at index I, column 2. So row I right now is the first one because I starts at 0. Column 2, that gives us 86. And then as I increases, we're going to be accessing values one by one within that column at index 2. So we get 86, 87, 91, 76, 71. So that is how we can access all of the values in a specific column. Now, if we want to do if we want to access every single element within a 2D array, we're going to need to use a set of nested for loops so that we can loop over all of the rows and all of the columns. So Here I have my nested for loops. I've got my r equals 0. R is less than my gradebook.length, r plus plus. My c equals 0. R and c standing for row and column. C is less than the gradebook at row r's length. So it's going to loop over the columns, c plus plus. And we're going to print gradebook at row column. So this implementation here, that is a row major traversal of this array. So I'm going to, each time I print something out, I'm going to print exam and then which number exam we're looking at. So here, R and C both start at 0. I'm printing exam 1. So we're printing the values for exam number 1. R and C both start at 0. We're going to print at RC 0, 0. That gives us 90. And then C is going to increase because that is the inside for loop. C goes up. Now we have row 0, column 1. It's going to give us that value 87. And then C goes up again, and we print that value. And we're going to keep doing that, keep shifting C up until C exceeds the outside of the array. C is now no longer less than my row's length, so that condition is now false. And we are going to exit our inside for loop. C is going to go out of scope. It's going to stop existing for a little bit. We're going to print a new line, so our cursor is now down here. That outside for loop has run all of its content, so we're going to loop back up to the top. We're going to increase our R variable. R is now 1. We print exam, and then we reinitialize C to equal 0. So C equals 0 again. And we print 65. C goes up again. We print 76. And we're going to keep going until C reaches the end, printing out that whole row. And this pattern is going to continue as we go down our rows until we've printed all of the exams in order. So that is our row major traversal, where we print out all the contents of each row one by one. Now let's look at a column major traversal. So here we want our column to stay steady while the row changes more frequently. So we've essentially just swapped the position of those two for loops. If you look back at the previous slide, our R for loop was on the outside before, C for loop was on the inside. Now C for loop is on the outside, R for loop is on the inside. So R is going to be changing more frequently, and C is going to be changing less frequently. Here I'm assuming that my gradebook at index 0 is going to be the same length as all the rest. So if my gradebook happened to not be a rectangle, this would not work super well. But we're assuming that we have a rectangular 2D array here. And everything else is just about the same. We're going to print out student number. So R and C both start at 0 still. So student 1, their first grade is at 0, 0. That's the value 90. Then R increases to 1, and we print out the value at 1, 0. That's 65. And this is going to continue as R goes down across the different columns, or not across the different columns, down across the different rows through this single column. We'll print all of the output values for student number 1. Now, when R increases, we are outside the bounds of our gradebook's length. R is now too big. We exit that inside for loop. R stops existing for a bit, goes out of scope. We print a new line. C increases to 1. We'll print the next student name, and then our inside loop starts again. So we'll print all of the different values within that column, et cetera, through all of our different columns. Right? Does that process, do those two different ways of traversing make sense? Any questions on either of those? All right. Now, something to keep in mind is that while column major reading of 2D arrays can be useful sometimes, because of the way that Java stores its data, traversing a 2D array in a row major way is going to be significantly more efficient. Your program is going to run much, much faster if you do a row major traversal than if you do a column major traversal. And that's just because of the way that 2D arrays are structured in memory. So accessing in that row major way is going to access your memory sequentially, where with a column major, you're going to have to jump around in your computer's memory a bit, which is going to take a lot longer, at least in computer time. So just remember, if you ever have to do a 2D array traversal, unless you really need to do that column major traversal, you should stick with a row major traversal. We can easily use nested for each loops to access every value within a 2D array. So we can say for each row, and the rows are going to be int arrays within our 2D array gradebook. So for each row within gradebook, and then for each int value within that row, we can print that value. So this is a very easy way to access all of the elements within a 2D array. And this will even work when the rows have different lengths, which is one benefit of using for eaches here that we can't say the same for with a with regular for loops, because those are very rigid in how many times they're going to loop across and down. So for each loops totally work with 2D arrays. If you've looked at the code for printing the 2D arrays that has existed in the code you've already looked at, you've probably seen these 2D array nested for each loops. And do a little bit talk of algorithms with 2D arrays. When we do linear search, that's the easiest kind of search to do with any kind of array. It will absolutely work with a 2D array. We just need to look through each row and perform linear search on that row. So here, instead of returning just an int, because I don't have one integer value for the exact location, I have both a row and a column. So we're going to return a string saying where we located it, both row and column. But we're going to get a 2D array, a value, and we're going to do a loop over our rows. And then inside, this is just regular linear search that we're doing on each individual row of our 2D array. So regular linear search. If we find the value when we're looking through one row, we'll say we found that value at index RC. Pretty simple. And then if we don't find the value, we want that not found return to happen after both for loops have finished, after we've looked at every single value in every single row. So we don't want to do this after the inside for loop. We want to do it after both for loops, saying it was not found anywhere in the 2D array. And if you remember back to the algorithms that we learned how to use with regular arrays, pretty much all of these are going to work with 2D arrays as well. Our mathematical ones, our analysis of the data, or elements ones, and then the shifting around. So structure is going to be almost identical. We're just going to use nested for loops rather than a singular for loop to perform our calculations. So we can do the math, we can do the data analysis, we can even do the shifting around of values. All are totally going to work. All right, any questions on any of the topics covered today? All clear?
I have a quick question, actually.
Yeah, sure.
So for the last problem on yesterday's work, I tried using a for each loop, like to access the element within the 2D array, but it wasn't accepting it. And then when I used the regular for loop, it did. So I was wondering if you cannot like modify an element in a 2D array, like using a for each loop, or is that possible?
Good question. So you are allowed to use a for each loop on the rows, but anytime you want to change a value within any array, whether it's an array or an array list, you can't use a for each loop to edit individual elements. So you could do a for your int or your, I think for yesterday's it would have been a string array row in your board, but you can't do a for each in here to change individual elements. You would need to do a for int I equals 0, I less than row dot length I plus plus, and then you change something within, you say row at index I equals some new value. So we can use a for each on the outside one because we're not going to be making an overall change to the entire array. We're going to be making individual changes to each row. So we can use a for each on the outside, but not on the inside. Does that make sense?
Yeah, thank you.
All right. Any other questions on looping with 2D arrays?
I had a question on 8.1, but like I can do it after like you finish.
All right. Then I'm gonna